Okay, fine. We'll do it together because you're wusses. So, let's see. Here I have my picture for my sum of angles, right? So I've got my alpha triangle, I've got my beta triangle, I dropped my vertical. Let's see, and I subdivided into a bunch of pieces, right? Okay. How did I know to do these pieces?
Yeah.
I don't know. I just started
'Cause I can
drawing
make a whole
things
bunch
that
of
seemed like they
triangles,
made sense.
Oh, okay.
So let me first note something about angles here. This purple triangle doesn't seem to have any angles I know in it, right?
Well, yeah, you have a 90.
I've got a 90 for sure because I made it that way. What else do I actually have in there?
Well, you got beta, and then there's using beta stuff.
Let's see. So,
Yeah, the beta triangle, you cut that 90 in half, so
Wait.
it's a 45, 45, 90.
oh, I don't know that I cut that actually in half. It just looks like I did.
Oh, really?
Yeah. If the beta triangle was narrower, that definitely would not be in
Wouldn't
half.
the other side, so kind of on the triangle right below it, be beta
Wait, if
for
you,
that angle?
if,
So if you look on the angle
hold
up to the top right a little bit, yeah. Of the triangle right below it, you know? That one, yes. Is that beta?
Why are you yelling?
That's a good idea. Why would this be beta?
Because it's the same angle. The side on the bottom of the purple, whatever color that is, triangle is perpendicular to the x-axis. And
Okay.
it's on the same line as that.
So you're good at making this observation, right?
Yeah.
That this angle here, right? And this angle here are the same?
Mhm.
Oh, bro.
Yes? Why are those angles the same?
because you have
They
two
just
parallel lines with a straight line.
Yeah, they're two parallel lines, right?
Yes.
Okay, so that would be on this picture, I think, alpha here.
Yeah, but I'm talking about different angles, not those ones.
So,
So I'm talking about,
well,
But if you have alpha, you can just subtract alpha from 90.
which
so
one
I'm
are you
talking
looking
about beta right here being the same as this one because this is parallel right here. So that would be kind of like,
at? Oh, yeah, that's problematic because beta is made out of this to this.
yeah.
See that?
Oh, okay, it's not to that, okay. I see,
Yeah.
never mind.
So I think we do need to find something like this. So let's see. I think I can know
The bottom right angle in that purple triangle is 90 minus alpha.
this one.
Yeah.
Think so? Sure.
I think so.
Okay, so let's see if we can straighten out why. So if I continued this, right? You guys see that?
Yep.
Then there's an alpha here, so there should be an alpha in there,
Yeah.
right?
Mm-hmm.
And there should also be, you guys see that? This one should also be alpha,
Yep.
okay? Which means that this one here is 90 minus alpha, or pi over 2 minus alpha.
And so is the
And this one's 90, and they should add up to
180.
180, so this one up here should be
Whatever's left over.
whatever's left over, which is 90 plus 90 minus alpha.
Why is that 90 minus alpha?
That one? Because that's a right angle there.
Oh, that, okay.
And this bottom bit was alpha, so the rest of it's whatever's
I
left.
didn't know that was a right angle. Okay.
And then that makes this guy up here alpha.
What?
How does that make that?
Yeah.
90.
Because 90 plus 90 is 180, right?
Yeah.
So out of these two, you've accounted for 180, except you took alpha out of it.
Oh.
So there's alpha left over.
Okay.
You guys see that?
Yeah.
So your purple triangle there has an alpha in the top. And then what about my orange triangle? Is there an angle in that one I know?
Which
A 90 and an alpha.
That's this little guy down here. That's got a 90 and an alpha in it.
Well, you got a 90 in the one like to the right of it. You got alpha and them in the.
Walk up there, Gabe.
Yeah.
Yeah.
And then if you find that very bottom piece, you can do whatever's on the top. piece.
Chill.
Yeah, we could do that. I don't think I need this triangle. But that's only because I've done this a couple of times. Okay, so let's see. I need to start labeling things. So, where's 1 in here? On one of my 4 triangles I pulled out.
The top right hand corner of the beta triangle.
Good. So the hypotenuse on the beta triangle is 1. You guys
Yeah.
see that?
Same as the alpha.
Same
Okay,
as
and the whole alpha triangle would be 1. I should probably note here that I didn't pull the whole alpha triangle.
It's just to that first point.
Yeah, it's just that cut off.
Oh, whoops, not that.
You guys see that?
Okay.
Okay, so let me see if I can answer maybe the easiest question. In the beta triangle, what are the 2 sides? Right, that's the full-size beta triangle.
Cosine beta, alpha beta, or
Cosine,
sine beta.
how about cosine beta for the adjacent side,
Sine
right?
beta.
And then
Yeah.
sine beta.
And sine beta for the opposite side. You guys with me on that?
Yeah.
Okay. Now in the beta triangle, right, I've discovered that this is sine beta long.
Wait, but wouldn't that have to be going all the way to the out of like the outer edge of the circle for that to be?
No, it should go to the x-axis in terms of beta. Right? So if I kind of cock my head at this picture, if I thought about this as the x-axis, right? Then I'm just going up the angle beta, this
Oh,
length.
okay. It needs to be 90 degrees with that.
Yep.
Okay.
Okay, so where else is sine beta in one of my other triangles?
The hypotenuse of the alpha.
Okay, the hypotenuse of the purple triangle is sine beta. Oops, sine beta. You guys all with that?
Yeah.
Okay, so what are the 2 sides of the purple triangle?
Square roots? No. Something to do with.
Okay, how about this? What's cosine of alpha?
That's what I was trying to figure out. Was it, that just have to be the, wait, shit.
Like, what does cosine mean?
It's gonna give you
Adjacent over hypotenuse.
Yeah, cosine should be the adjacent side divided by the hypotenuse. Well, the hypotenuse on this triangle is sine beta,
Yeah.
right? So the adjacent side here on your purple triangle is how long? Cosine alpha times
Sine.
sine beta. Let's cool with that. So that's this vertical, right? I'm not going to write that in there because it's too much.
How would you explain the sine beta without knowing the other triangle?
Without knowing, I couldn't.
You couldn't?
Yeah, I would have no clue.
Okay.
How about this other side of the purple alpha triangle?
It'd have to be tangent then, right?
Okay, we could make that with a tangent. It would.
Sine beta squared minus, or the square root of something to do with the Pythagorean theorem.
No, you could do that. You could. And you could do the tangent thing too. They're both messier than they need to be. This is the opposite one, right?
Yeah.
So the sine of alpha should be the opposite side divided by the hypotenuse, right?
Mhm.
So if you do the exact same thought, right? Sine of alpha is the opposite side divided by sine of beta. Then the opposite side should be
Oh,
Should
sine
be
beta
sine
times
beta
sine alpha.
times cosine.
sine alpha sine beta.
Yeah.
So all see that? Okay, so that's these 2 sides. taken care of. All right. What other triangle did I get out of that original beta? Out of my black beta triangle here, I think I got another side of one of my other triangles. Which one was it?
Yeah, you got the cosine beta for the blue triangle.
Okay, cosine beta, right, should be this distance here,
Mm-hmm.
which is the hypotenuse of that blue alpha triangle. So this side's cosine beta. And then we can do this exact same thing. So what should this adjacent side on that blue alpha triangle be?
Cosine alpha.
Cosine alpha times the hypotenuse on this triangle is cosine beta. Okay, see that?
I'm still confused on how you're getting like multiples. Like, what are you doing multiplying those things? That doesn't make sense.
Oh, I'm solving. So, like on this one, right? I know that the cosine of alpha is the adjacent side on that triangle divided by the hypotenuse. Right? Like, this is just what cosine of alpha is. Right? It's just the adjacent bit by the hypotenuse. In the blue triangle, the hypotenuse is cosine beta. So I'm swiping hypotenuse and putting cosine beta in there. And then I want to know the adjacent side. So I'm just multiplying both sides by cosine beta.
Oh, okay. I see.
Cool?
Makes sense.
Okay, so I got this. How about this side? Check your understanding. What's this side then?
That would be the sine, and that's the opposite over hypotenuse.
Yep, so sine alpha
Times cosine. beta.
times cosine beta for that guy. And then the, okay, so that's this and that. So I think I already have here I have here the sine formula written down. I just have to dig it out. You guys want to see the sine formula?
The positive one, sine. Cosine.
So the sine of alpha plus beta should be this vertical distance, right?
Mm-hmm.
You guys see that? Which is the purple vertical plus the blue vertical. You guys see that?
Oh, okay, so that's cosine alpha.
So I should be able to write down, sorry, sine of alpha plus beta, right, is the, what's the vertical part of the purple triangle?
Cosine alpha times sine beta.
Cosine alpha sine beta, oops, can't write. And then I should be adding to that the vertical bit of the blue, which is
sine alpha sine beta.
sine alpha cosine beta.
Look at that.
So that one came out of the blue, and this other one came out of the purple. You guys see that? Okay, so where do I get the other one?
That blue one surprised me. Just came out of the blue.
God damn it. All right, so the other one, right? The cosine one. Where's the cosine length on here someplace? You guys see it? This one's a little harder to tease out. I made that orange triangle for a reason, but I'm not going to have to use it as a triangle. So where's the cosine of alpha plus beta on the picture here?
It's the this big
The
triangle on
orange
the bottom, and then the small purple triangle added together.
Close, yeah. So this piece here, right,
Plus the rest of the blue triangle.
is the cosine of alpha plus beta. That's really just the bottom of the orange triangle, right? That should be cosine alpha plus beta on the bottom. You guys all see that?
Mm-hmm.
And the way I made that is not blue plus purple, but blue out and then back purple. You guys see that? So this blue one is how long?
Cosine alpha cosine beta.
Cosine alpha, cosine beta, and the purple one on the bottom is
Sine alpha sine beta.
sine alpha, sine beta. You guys see that?
Mm-hmm.
So my cosine identity, I can now write down in the margin here, is the cosine of alpha plus beta, right, the side of the orange triangle, that bottom side of the orange triangle, is you go out the bottom of the blue and then back the purple. So you do
Cosine alpha
is cosine alpha cosine beta
minus
minus sine alpha sine beta. You guys see that?
nice.
So there's your two sum of angles trig identities. Yay! Right? And if you want to trace it out this way, you have to remember where to draw the lines and how to solve the picture, which is a giant pain in the ass,
Yeah.
right? Because this took, what, like 20 minutes for me to do this? And yeah, I vaguely remember how this picture goes.
You have to wait for us.
So you guys might want to just throw these on the back of a flashcard. But there are only 5 trig identities I really care if you know. The Pythagorean trig identity, these two, and the half angle identities. Cool? The half angle identities you can get out of these ones in much less time. Cool? We'll talk about the half angle identities another day.